The topic of discussion for today's class is knowledge representation. What is knowledge representation? We know we have stored many things in our brain. We have stored right from alphabet, which is A, B, C, D, sentences, vocabulary, grammar, technical knowledge about different subjects. Whatever you are learning all these years, they are stored in your brain, and that is knowledge. How to represent knowledge in the brain is still uh, an unknown task. How actually A is stored in our brain. However, in AI, some sort of representation is required so that AI systems would also store some kind of knowledge which helps AI systems to make decisions and to plan, to understand, to respond, to do all these types of tasks. Knowledge is essential. Without knowledge, how will AI know what is happening, what is the meaning of something? Therefore, knowledge representation is a very important issue in artificial intelligence, and it has to be understood thoroughly in order to understand how artificial intelligence take decisions based on the knowledge that is stored within it. All right. Coming to some of the properties of AI system with respect to knowledge, learning. What is learning? We are learning. What are we learning now? Knowledge representation. Topic knowledge representation. We are learning. We will know some important details about this knowledge representation. We store in our mind, and later, in exam, if a question comes about knowledge representation, you write about it. And learning is the process of gaining the new information, uh, the new knowledge about something which is unknown to us, and we form a kind of representation in our mind and we store it. Likewise, AI systems also learn. They learn, and that learning refers to the capability to acquire new knowledge, behaviors, understandings, and so on. It does not simply involve adding new facts, but information has to be classified to avoid redundancy and replication in the existing knowledge prior to storage, to enable information retrieval, easy retrieval of the information. And there are number of ways in which knowledge may be gained, such as by reasoning and logic. We learned predicate calculus and propositional calculus, predicate logic, and propositional logic. Through that, using resolution method and truth table method, axiomatic method, deduction method, an AI system could uh, reason, could uh, give the conclusion or the derivation or the some kind of new information about the existing knowledge. And by experience, by observing the world, by mathematical proof, by scientific method, these are all the ways in which system acquires new knowledge, through reasoning and logic, or by experience. By experience means if you train this AI system 1000 times, it implies that AI is learning something for 1000 cycles, and its experience would increase as the number of cycles increases. Consider AI system was trained and made to learn for 100 cycles. After 100 cycles, AI would learn out of 20 new information elements, it learns say 5. When the number of cycles increases from 100 to 200, it would learn more 5 new information. For 300, it learns something more. For 400, it learns everything about the data which has been supplied into AI system. And suppose if you are increasing this data from 20 to 100 or 200, then 400 cycles are not adequate to make AI system learn. You have to go for 1,000 cycles. Likewise, with experience, AI system learn by observing the world in the sense that when a robot now look at the case of Sophia robot. You might have heard about Sophia. It is a robot. What it does is it can see, it can hear, it can talk. It has got lot of knowledge. It can walk and it can observe the world. And by observing the world, by seeing, suppose if Sophia is taken to uh, a conference and Sophia look at the conference hall and understand that there are 100 members. So by observing the world, it get to know that there are in a conference perhaps there would be 100 members. Mathematical proofs, of course, mathematics is a essential component of artificial intelligence, and through mathematical proofs also AI system learns, and by scientific methods also it learns. This is all about learning. Efficiency in acquisition. This refers to the ability to acquire new knowledge using automatic methods or wherever possible rather than relying on human intervention. A teacher, so consider there is a teacher and there is a student. Teacher teaches a student, for instance, take this topic knowledge representation. What the student does, understand the basics. Anyway, during the class, basics will be taught and the content would be uh, restricted with the syllabus. Whatever is the syllabus, the same topics have to be explained. However, student would like to go in detail about the topic, would like to understand more. Then student need not ask teacher because there are other methods. There are books available, there are YouTube lectures, there is a Google where a student can find information about new topics, new areas. Likewise, there is a human, there is AI system. This AI system has been trained um apparently using different methods, and this AI uh, would acquire new knowledge without any human intervention later when it starts learning on its own by experience or by logic or by observation. Next are properties representational adequacy. It refers to the ability to represent the required knowledge. How to represent the required knowledge? That's quite important and significant task. If I say A, You know that you put one slant line, another slanting line, and one sleeping line. Like this, it is taught when we are kids uh, in kindergarten. We were taught like these lines are called as these, names are defined, and then how they are combined to form different letters. This is nothing but representing a. A has its face, and that you are doing it through two slanting lines and one sleeping line. Likewise, whatever knowledge is there in AI system, it has to be represented in a format which system understands and can utilize it for further processing and other related tasks. Inferential adequacy. This refers to the ability of manipulating knowledge to produce new knowledge. Consider we humans know that if there is a cloudy, if the sky is cloudy, then what do we infer? We infer that it may rain. When we are in college, we say that look at the sky, it has got too cloudy. Perhaps it rains within an hour or half an hour. Let us go back. What is that? It rains and go back and all that is the new knowledge that you have produced from the existing knowledge. What is your existing knowledge? Your knowledge is sky is cloudy. This is through observation you got to know. However, you are not limited only to this. This lead to some new knowledge. You um, infer that rain might occur. Likewise, an artificial intelligence system, if we tell artificial intelligence system that uh, suppose Ram likes cricket, then this is the existing knowledge. Then AI might infer that Ram plays cricket because he plays cricket, he likes cricket. Or it can be said Ram likes plays cricket, then AI would infer that because he plays cricket, he might like it. Because he likes it, he plays it. Like that, new knowledge is inferred from the existing knowledge. These are the important properties of AI system. The next topic is approaches to knowledge representation. When you talk about A, how do you represent A? I said that there are two slanting lines and one sleeping line. This is capital A. If you talk about small a, its representation would look different. Likewise, in AI system, there are several approaches to represent knowledge. It's not just one. This is one way. Relational table. In relational table, information is stored in the form of rows and columns. Right? Information is stored in the form of rows and columns. And the one row represent one entity or an object. All right. This is one object. When you talk about John, what what knowledge about John is stored in this table? His age, his gender, his qualification, his salary. These are things that are stored in the table. From this, what we can infer? By reading this first row, we can infer that John is a qualified person. John is an employee, John is working, John is in late 30s. How are we inferring this information? Through the existing information. We can easily obtain the answers of the following queries. What is the age of John? If we ask the system, what is the age of John? System would first find the John and its age, which is 38. How much does Mary earn? Go to the third row, and in this the last column gives the salary. This is nothing but earnings. When we ask AI system how much does Mary earn, AI system should know earning means salary and should return 25,000. What is the qualification of Mike? What AI system has to do? Again, read from this table the second row and the qualification column which states undergraduate. He is an undergraduate. So next one is knowledge represented as logic. First method is knowledge represented as a relational knowledge. Okay, this is first. Second method is as logic. How do you represent as a logic? Uh, if the knowledge is represented in some formal logic. What is formal logic? We learned predicate logic and propositional logic. Those are formal logic methods. Example, all humans are mortal. This you cannot represent it in tabular form. When you want to convey the message that all humans are mortal, you cannot store this in the form of a table. How will you store this in the form of a table? Well, you can't do it because this is not something which has got some attribute. Is there any attribute here? It's no attribute. Therefore, relational approach cannot be used for this. Um, Having said that, it can be easily represented in predicate logic. Here, in predicate logic, there is a universal quantifier for all x. This is a bound variable. The variable has been bounded to a universal quantifier for all x. What is x? X is a human of x. Human of x means you put in place of x any human, and here you are saying for all x. It means that whatever x value is, it implies that it is mortal of x. When this is the knowledge, this is the statement which says all humans are mortal. This can be easily represented in the form of a predicate logic which states that for all humans, uh, instead of writing for all humans, you are taking a variable x. For all x, x is a human, implies x is mortal. Suppose in place of x, if you put John, human of John, what does it implies? What does it, what can we infer? We can infer that John is mortal. All right. The advantages of predicate logic approach is that we can represent set of rules, derive more facts, truths, and verify correctness of news statements. All this would be done through this. You can represent a set of rules, derive more facts, truths, and verify the correctness of news statements. Uh, the next way of representing knowledge is procedural knowledge. Procedural knowledge is encoded in the form of procedures which carry out specific tasks based on relevant knowledge. For example, there is an interpreter for a programming language which interprets program based on the available knowledge regarding the syntax and semantics of the language. If you compile a Java program using Turbo C, will it compile? It will not compile because the compiler has got the syntax and semantics of C language. So it understands only C language. It will not understand any other language. That is the knowledge that it possesses. Beyond that knowledge, it knows nothing. For instance, we are learning computer science. We know about C, C++, Java, and other subjects, operating system, DBMS, AI, and so on. When someone asks you a question from chemistry, advanced chemistry or advanced physics, which UG level or PG level, you may not be able to answer because you have no knowledge about that. Your domain is computer science domain. So whatever is available in this domain, you know about it. Perhaps in computer science, a domain which has all the subjects that are specified for your program, for your degree. You might know only that. If there is something beyond this, you might not know. So every program, every application, every system that is developed would have limited knowledge about that domain. It would not have a general information about everything. This is procedural knowledge. And this advantage of this approach is that it is domain specific knowledge and can be easily represented, and the side effects of actions may also be modeled. There is a program of completeness. However, there is a problem of completeness and consistency in procedural knowledge. Completeness means beyond a particular case, it does not know anything else. It knows only the case with which has been implemented. All right, that is complete. Means it is not complete. Consistency means that all deductions may not be correct because it has got very limited knowledge. Therefore, all deductions might not be correct. We can extend the approaches mentioned above. What are the approaches that are mentioned above? There are three approaches. First one, tabular method. Second one, logical method. Third one, procedural method. These three methods have been discussed for the knowledge representation. These have been extended now uh, into something called as hierarchical structure that allows inheritance mechanism. And the knowledge that is organized in this form uh, using semantic network and frames is referred to as inheritable knowledge. When you represent knowledge in the form of a tree, like this, consider an analogy. Uh, there is a grandparent, there is a parent, there is a child. Child would inherit many properties from parent and grandparent. Parent would inherit from his parent. Through this structure, we know that there is knowledge that is inherited by the most specific nodes. All right. The same kind of mechanism is introduced for knowledge representation in AI systems through hierarchical mechanism, hierarchical structure. This here you have got some knowledge. From this knowledge, you derive some new knowledge. From uh, another some knowledge, and like that it goes on. Therefore, it is also referred to as inheritable knowledge. This inheritable knowledge is organized in the form of semantic network and frames. Here we can put semantic network as the fourth method of representation, frames as the fifth method of representation. Already we learned tabular method, logic method, and procedure method. Now, next we would learn semantic network method and frames. Uh, then the next topic deals with representation of knowledge using semantic network. So the basic idea applied behind semantic network is that meaning of a concept is derived from its relationship with other concepts, and that the information is stored by interconnecting nodes with labeled arcs. Consider this paragraph. Every human, animal, and birds are living things who can breathe and eat. This is some statement, a sentence, or it can be called as a knowledge. How this knowledge is represented? In this knowledge, there are concepts, there are relationships. All right, that together combine to form semantic network. How is concept represented with a node? How is relationship represented with an arc? And such knowledge could be represented using a structure called a semantic network or semantic net. And it is represented in a graphical notation where nodes represent concepts or objects and arcs represent the relations between two concepts. And it can be described as a directed graph consisting of vertices. What does vertices represent? Concepts. And edges that represent relations between the concepts. If I say that Mr. X is the father of Mr. Y, here what is the concept and what is the relation? Mr. X and Mr. I are two concepts, and relation is Mr. X is father of Y, or we can say Y is son of X. The relations represented in the figure by bold links, and they are defined as is a or inst. Inst means instance. Is a relation connects two classes where one concept is a kind or subclass of another concept, like father, son, likewise vehicle, four-wheeler. One node is the subclass of another node. That is a. A four-wheeler is a vehicle. It represents instance, and it states that a particular object is the member of a class. For instance, if example is taken as man, and there is a um, person called John, it can be said as John is an instance of man. All right. Look at this semantic net. This is semantic net. In this semantic net, we have got nodes. What are nodes? These living thing, human, man, woman, John. These are concepts. From where we got this? We have to go back and read this paragraph. From this paragraph, we have obtained that semantic network, which is a graphical notation. What does it says? Every human, animal, and birds are living things who can breathe and eat. Let us see how it is represented. Living thing. Okay. So first superclass is a living thing. This living thing can eat, can breathe. Alright? All living things can eat and can breathe. And in living things, there are animals. Animal is a living thing. Bird is a living thing. Human is a living thing. We got three different categories or classes. From this paragraph only we are uh, extracting information from this paragraph. How are we extracting? When we say human, animal and birds are all living things. Living thing would be the superclass. Animal, human and birds is a kind of living thing. We got is a relationship between living things and uh, human, animal and birds. It is said that all living things can breathe and eat. Instead of having these two properties associated separately to these uh, objects of human, animal, and bird, what has been done? These two properties have been associated with living things, not with the subclass. These are subclasses. This is superclass. Superclass can eat and breathe, and these are is a kind of that. Further, all birds can fly. Every man and woman are human who have two legs. Let us see how it is represented. All birds can fly. Birds. There is a bird here. Bird properties can fly. This dashed line is there, no? That is showing the property. This dashed line. Birds can fly. It is a property associated with birds. If there is a bird, all the birds would fly. From look, this is not general. This is with respect to this paragraph. Every man and woman are humans who have two legs. Man and woman. Man is a human. Woman is a human. Man and woman both are humans. So we got this relationship. Man is a human. Woman is a human. I think in these two legs are missing, no? Man and woman. Where is the two legs attached to this? It's not attached. Every man and woman are humans who have two legs. So this should be here. There should be some property. Dashed line have two legs. Every human has two legs. Again, this is with context to this paragraph. This paragraph says that we are representing this knowledge. This is some knowledge. A cat has fur and is an animal. Cat is animal and it has fur. All animals have skin and can move. Animal has skin, animal can move. These are properties. A giraffe is an animal and has long legs and is tall. A giraffe is an animal and giraffe has long legs and giraffe is tall. Means um, it is with respect to height. Tall means its height. It denotes its height. A parrot is a bird and is green in color. John is a man. So parrot, where is parrot? Parrot. Parrot is instance of bird and parrot's color is green and John is a instance of man. Parrot means it is one particular um, occurrence of a bird. You can have pigeon. Pigeon is also an instance. It is not is a relationship. It is instance relationship. Students, you understand? This is knowledge representation using semantic graph. Other relations such as can, has, color, height are known as property relations. These have been represented by dotted lines. We saw already. And it is pointing from the concept to its property. We saw that. This is concept, this is property. Is this structure property? Inheritance is easily okay. In this structure, property inheritance is easily achieved. By looking at this, it's so easy to know that human is a living thing, man is a human. This kind of inheritance. For example, the query, does a parrot breathe? This is a query. So how will you resolve this? How will you answer this? You start with parrot. Parrot is a bird, instance of bird. Okay, parrot is an instance of bird. And bird is an instance of living thing. Living thing, all living things breathe and eat. Therefore, the answer that is obtained from this semantic net is yes. Because it is inheriting, parrot is inheriting these properties too from living thing and this property from fly property from bird, breathe and eat property from living thing. And here concepts connected with prop links. Instead of having here like separately putting these properties, it has been combined into one uh, ellipse. And in this ellipse, we mention all the properties belonging to that particular concept along and the connection is a dotted line on which prop is written. Prop means property of these. All right, next. How is inheritance implemented in a semantic net? 1 minute, students. Sorry about this. Okay, we are here. How is inheritance represented in semantic net? Hierarchical structure of knowledge representation allow knowledge to be stored at the highest possible abstraction, and this abstraction reduces the size of the knowledge base. Look at this algorithm. Property inheritance algorithm. Input is object and property to be found from semantic net. There is an object, and what are the properties that are associated with this object have to be found from semantic net. That is the input. The output is it returns yes if the object has the desired property, else it returns false. Take an example. Does, where was it? Here. Does a parrot breathe? Consider this. So, parrot is the object, breathe is the property. Here, object and property both are given as input. Parrot and breathe. This algorithm returns yes if the property is associated either with the object or its immediate superclass or uh, its superclass. Okay, or if it belongs to the parent's parent or it belongs to the root, wherever it belongs, that is returned if it is there. If it is not there, it returns false. What is the procedure to find that? Procedure is find an object in the semantic net. First, you have to find an object. Here, the object which we have considered is parrot. Found is equals to false. All right, you are initializing found to be false. While object is not equal to root or found do, if object is not equal to root, if it is equal to root, then there is no need to go down the line. If it is not equal to root, then only we have to traverse the tree. Uh, or found means if found is equal to true. Presently, the found is false and parrot is not the root. Condition satisfied. Enters inside the loop. If there is an attribute attached with an object, then found true. Else object is equals to is a object comma class or object is equals to inst object comma class. Here we start with this tree. It is checked at this if the property is present. If is this property attached to this root? If it is attached to root, it means that all the children, every node in this tree would have inherited that property. What is our property? Breathe. Breathe is there attached to root. If there is an attribute attached with the object, yeah, it is attached with the object. Okay, we have started with no, no, no. We are at parrot. No, we are at parrot. So that property is not attached to parrot. This fails. When this fails, we have to change the object. Object is equals to is a object comma class. From parrot, okay. This is instant relation. So object is equals to inst object comma class. We because object this is an instance of class bird. Parrot is an instance of class bird. We reach bird. Is bird has property attached to it, which is breathe? No. No means again one more cycle. And in this cycle, it is checked that it is attached to living thing. Then it evaluates to is a, you obtain living thing, and breathe is attached to living thing. Therefore, it returns yes, true. When it returns true, if found equal to true, then report yes, else report no. Found is true, so yes is reported. All right, students, this is about how this inheritance, using inheritance, we can obtain the knowledge. This is the rules written in prologue. Prologue is a programming logic. It is a kind of programming language. This was Prolog and Lisps are the two early successful languages to uh, to create AI systems. In order to create AI systems, earlier in 50s, 60s, 70s, 80s, 90s, Prolog and Lisp were used for AI. Now it is changed to Python. There are other programming languages as well that can create AI systems. The predominant programming language is Python that performs all the automation tasks. These prologue facts from that tree we can derive as living thing is a nil. Human is a living thing. Because living thing is the first one. Therefore, it is not belonging to any class or any super class. Therefore, this is null, nil. Human is a living thing. Animal is a living thing. Bird is a living thing. Man is a human. Woman is a human. Cat is an animal. John is an instance of man. Giraffe is an instance of animal. Parrot is an instance of bird. These are facts. Instance facts. These are easy facts. Property facts are um, property belonging to living thing is breathe, also eat, to humans two legs, to animal skin. These are the properties that belong to these concepts. All right, these are prologue facts. And inheritance rules in prologue. How inheritance rules are coded in prologue. Instance x comma y is equal to x is an instance of y. X is instance of z, z is subclass of y. In this manner it is written. For instance, for subclass, x is a y, x is a z, z is subclass of y. Alright, we can write in this manner or in this manner based on the structure. Property rules, we write prop x comma y, means x is a property of y, or y instance z, mm, and x is a property of z, means y is an instance of z, x is a property of z. Y is subclass of z, x is property of z. These are the ways in which prologue write the rules. English query, is John human? It is in English. Is John human? What is in prologue? This is question mark. Instance John humans, means is John an instance of human? The answer would be yes from the tree. Okay, from the tree we'll get to know that the answer to this is yes. All right, students. Likewise, all these questions are there which have been coded in prologue words and output. Please go through this. In tomorrow's class, we will look at extended semantic networks for knowledge representation. Okay, semantic networks we have learned, and now uh, in next class we would learn extended semantic networks. All right, students.